So cytokines play an essential role in the regulation of inflammatory responses to the immune system, particularly to also diseases such as sickle cell disease and then malaria infection. But in areas where malaria is endemic, individuals tend to develop asymptomatic infections where you have the parasite in your blood, but you fail to exhibit the phenotypic characteristics that come with the disease. The studies have shown that cytokines mediate the pathogenesis of these diseases, and also studies have shown that in individuals who have or who are infected with malaria and develop asymptomatic infections, they have increased levels of pro-inflammatory cytokines and also equal levels of anti-inflammatory cytokines to counter the effect of pro-inflammatory cytokines that they exhibit. Also, in sickle cell disease, individuals are shown symptoms such as severe pain, crisis, and anemia. And the cytokine profile there shows that pro-inflammatory cytokines are normally increased in this condition. So in this study, we decided to investigate the effect of cytokine mediated inflammatory responses in asymptomatic malaria children with different hemoglobin genotypes. That is the AS, AC, and SS, and also the normal hemoglobin, that is AA. And so in this study, we obtained approval from the College of Basic and Applied Sciences and then the Ghana Education Service. And then we measured our cytokines using the Sandwich ELISA assay. So then these are the demographics of our participants, showing the hemoglobin genotypes, the malaria status that we measured using the RDT, and also the sex and the age of the participants. We recruited a total number of 190 participants, and these people were school children from 3 communities, which are Esetuare, Tomefa, and Begro. These communities are known to be highly endemic to malaria, and all the positive samples were asymptomatic. So in the first figure, in the first result, we measured the total or the general expression of the cytokines in the population. So we measured, we took 2 cytokines that are pro-inflammatory, and we took another 2 cytokines that are anti-inflammatory. For the pro-inflammatory cytokines, we use IL-6 and IL-8, and also the anti-inflammatory cytokines, we use IL-4 and then the IL-10. So the IL-6 role in the immune system is to mediate fever responses and also acute phase responses, and it is antagonistic to the TREGs, that are the regulatory T cells. The IL-8 is a chemokine that recruits its target cells to the site of infection, normally neutrophils and the other granulocytes, and also induces phagocytosis and oxidative burst mechanism once they arrive at the site of infection. The IL-4 normally mediates allergic responses, and also the IL-10 inhibits the production of other pro-inflammatory cytokines, including the IL-6 itself, IL-2, IL-3, and the tumor necrophytic factor, and the interferon gamma, and so on. So we measured to see whether which cytokines correspond with asymptomatic infection. So we did our analysis, and we saw that we found out that the cytokine IL-10, which is an anti-inflammatory cytokine, corresponds or is significantly expressed in individuals who are asymptomatic than those who were not infected. The rest were not having any significant association, and this result may have confirmed that actually individuals or the children that we recruited for these studies may actually be asymptomatic because of the anti-inflammatory effect of IL-10, which is dampening the pro-inflammatory responses that are associated with malaria. So then we decided to find out the relationship between the various hemoglobin genotypes and then inflammatory cytokines among the cohort. So here for figure A, which is for IL-6, we've seen that IL-6 individuals who have HbAA, that's the normal hemoglobin, exhibited significant level of IL-6 than seen in AC and AS, with significant values of 0.01 and 0.0031 respectively. It's worth noting that even though there is no association seen in the expression in individuals who have HBSS, it was the one having the highest expression of the pro-inflammatory cytokine IL-6. For the IL-8, we have a fair expression or a concentration of the various cytokines, and this may just infer that though hemoglobin genotypes modulate the function and then the morphology of the red blood cells, they may not be directly involved in the expression of IL-8 at the genetic level or the molecular level. For IL-4, we've seen that the individuals who are positive or who are sickle cell anemic express the highest level of IL-4, and this was significant because of its p-value, which is 0.0022. Also, similarly, individuals who have the genotype AC have significant expression of the IL-4. By looking at our scale, we could see that the expression of IL-4 in individuals who are HBSS was around 30 picogram per mil. However, the pro-inflammatory cytokine here had a mean concentration of around 100 picogram per mil, and this may not be enough to dampen the pro-inflammatory effects of the IL-6 that we've seen here. Remember, also IL-4 normally mediate allergic responses, so this may not be enough just to counter the effects of the pro-inflammatory cytokine. For IL-10, which is the main regulator of the immune system, you could see that the highest expression was seen in individuals who have the hemoglobin genotype HbAA. As seen, we could see that there is a significant expression as compared to those in AS with p-values of 0.002. Notably, we could see that individuals who are HBSS have no or little level of IL-10, which will also not be enough to counter the effect of the IL-6 that is seen in the sickle cell anemic patients. So we could infer that individuals who are having the hemoglobin genotype HBSS may actually be at crisis, which is associated with sickle cell disease. This may not be due to the parasite infection, but it is just a graph that is communicating to us that these individuals may actually be in crisis. There are some limitations to my work, which are the total number of individuals who have who we use for the HBSS participants, and which was only 6, and this may not give a very high statistical power for our studies. So in future works, we hope to recruit individuals with or our sampling method should include individuals who have more of the sickle cell genetic makeup, so that we can see what is actually happening in the immune system of these individuals. And so these are my references, and my name is Timothy Lecha. Thank you.